Future Hacker. Life. Path. Future.
Hello, everybody, and welcome to the international edition of Future Hacker. This is your host, Maria Taiji, and today we're talking to Firas Khalifeh, also known as the Elon Musk of the smartphone industry. Hi, how are you? How are you doing today, Firas?
Hi, Maria. I'm good. I'm great. Thanks for inviting me to the show. I'm very excited.
So, Firas started programming at the age of 15 and later focused his studies in computer engineering. Later on, he specialized in material science, which is the focus of our interview today. The company he founded that is building mobile phones out of carbon fiber. Firas was awarded by MIT as the top 10 innovators under 35 years old. That's so impressive. So Firas, what's your story? How did you get into building carbon phones? You mentioned to me that you began by yourself, running throughout China to visit factories. Just share with our listeners how you got where you are today.
The reason I started with building a smartphone and mainly the ambition behind the consumer electronics a few years back behind that is that I used to like the intersection between the software, hardware, media, art, and business. So I used to do a lot of prototyping for futuristic products. Those futuristic prototypes, we used to took so much efforts to build them and just showcase them once. From there, I was like, okay, I'm done with that. I really want to build a product that goes in everyone's hand, right? And that's smartphone is the most accessible product that can go daily with you all the time. From there, it was the ambition to build a smartphone, and it's always like it's a crazy idea to build it, especially if you're not based in Asia, you're so far away from access to supply chain, etc. So when we decided to build a smartphone, it came together from the idea why we should build it, what's going to make it different. And there was a frustration of the materials that exist right now in the industry. The products that you see today of the smartphones, if you see like the latest iPhone coming one after the other, or Samsung, etc., they all have one problem in common, is that you only see like new features of camera, processor, screen, etc., but the form factor is not changing. And that's one of the biggest problems that we thought, okay, maybe we can address something here. So we're not solving a problem in particular, more like opening an opportunity that people don't expect even that would exist. Because you might say, why do I need a lighter or thinner or stronger product, right? But unless you have it, then you realize what we're talking about here. And the ambition came from the intersection between computer, hardware, software, and also the ambition for space, where you see super materials being used in the space industry, Formula One cars, and super material industry that requires this super material. And we were looking why that doesn't exist on any of our consumer electronics. And then we start to tap into it. We start to research. We put our all my money into the project at the beginning before we get investors to start really to understand why nobody did it. And then we realized that actually some of the big guys were trying to work on that, but they're aware of the problems, but the problems for them are bigger than only what the limitation for us. So economy of scale is one of the biggest thing. So they left the problems, the technical problems, together with a manufacturing a scale problem altogether, and they left the whole thing with no hope to continue on top of that. You can, just to give a comparison to the audience here, is that you can compare it to Tesla, right? Tesla, they started almost 17 years ago or more, and the ambition for them was to build an electric car and then start with a roadster, small scale, and then scale it up, and then find ways to scale up battery production, take it out, not prototyping it, but really produce it, and then scale it up and make sure the whole industry goes into that. So you're making technological advancement, one, and you're also solving sustainability problem, and you're making sure that the whole industry start to adopt that, and you become the leader. And I think this is our positioning as well. We want the industry to start to use composite materials. Carbon fiber is one of them. We want them to stop using plastic. The advantage for the consumer are huge. Usually when you talk about sustainability, it's about compromises. So we wanted people to have that, the feeling of miniaturization is when the products become super thin, extremely light, and very strong. At the same time, taking care of sustainability from production point of view. That's where we started. So getting back to the detail of the question, when we started to go to Asia, mainly China, and we start to visit factories. I remember when I first started, I have zero contacts in the industry and I know nobody whatsoever. Just like looking around and searching on Alibaba and go to Huaqianpei in Shenzhen and asking people, try to really hacking the system and try to understand how to build things. I didn't know what is a contract manufacturer is. I didn't know what's an ODM. I was just learning theoretically online while also learning on practice. One of the things is that, I wouldn't call myself a material scientist at all because I'm more of I hacked into my way into material science, and especially in the composites, is mainly for the purpose of building a smartphone. So I did whatever it takes to start to understand that and start to understand materials and open research papers and publish by real researchers and try to understand the barriers of the materials. Yeah, well, at the same time, understanding what's the requirement to get a composite material to be used on electronics, because nobody has done that before. And then you realize that there is electronics, signal radiation problems, electric conductivity problem, grounding problems, thermal problems, and other things. And then you realize, wow, this is really huge. Where you got to start? So we start to understand more and more, start to build supply chain, really running around on a cab in China and going from one supplier to another. At some point where you go to suppliers who don't speak English at all and having a translation app with you, because even translators, sometimes they don't understand technical stuff. So I start to rely on translation app to run between factories and put the translation app on the table and have a discussion with the people. So that was in the early days until we started to have more people, get investment. So these steps was required at the beginning to build what we call the Carbon 1 Mark 1. That was the first prototype that we built, where we give it to, we show it to investors, retailers, operators. We show it to consumers. We show it in exhibitions. So with the Carbon 1 Mark 1, it was good validation without even selling it directly to consumers. It was good validation to know that there is a market need. Distributors, retailers, operators, they want this. Investors were excited. So we raised money. We were planning to get into a proper good investment. It was never good for such a project because on this kind of projects, you better raise at least 10 to 20 million to make a new flagship smartphone. Nevertheless, it has to be innovative in the materials that we're doing. So it's really nothing but what we raised to be able to pull out the job. And so we raised some money, beginning 18, we moved ahead. We start to build the supply chain properly. We start to find the right partners, the right people to get this through. And now we're building the Carbon 1 Mark 2. We are almost finishing it. We should be able to put it in mass production and shipping in beginning Q1 21. That's where we are.
That's such an amazing story you have, Firas. And you also have such a great market out there when it comes to using sustainable materials, right? As you mentioned, one of the main challenges when dealing with innovation is how to turn a concept and a prototype into this marketable product. And as you said, it takes so much effort just to develop those prototypes. It's not only about getting buy-in from investors, but you need also to involve the whole supply chain, customer support, the replacements availability, and so on and so on. So which were the main challenges you faced? And it will also be great to hear, if you could, not only the successful part of the story, but also what would you have done differently next time?
Oh, that's a great question. I think what I would have done differently, I think a lot of things, 90% of the stuff I would have done it differently because it just everything started, you start wrong. That's what they do in startups. You got to do something, but you got to start from somewhere. And then you keep steering into the right direction. Yeah, getting investors was it was very difficult because getting investment for hardware is relatively hard. Hardware that's building a smartphone in a very saturated market is extremely hard. It requires really smart investors to understand what are we doing differently and what's the future of that. And also being in Europe doesn't make it easier as well for that type of investment. So we managed to get that, but still the other hard part is the supply chain, product development, engineering, resources. Because when you go to the supply chain, is that like even knocking the doors of the big players, the big suppliers, they only work with big players mostly. They're not used to have a startup knocking their doors, and there's no way for them to work like this. Everything goes so slow and so big and so quantities and huge amount of money behind it, and you need to pay engineering fees, blah, blah, blah. It was not easy at the beginning. And of course, we wanted to build a flagship smartphone. We wanted to build a phone that's not only super thin and light and special in the materials and the sustainability aspect of it, but also we don't want it to be sold at a compromise of specs. We really wanted to give you the best, like a processor, chipset, the best AMOLED there, memory, etc. So the whole package, you cannot do it on your own. You need to have good supply chain for that. Yeah, I remember early in the days, I give you an example. For example, working with a company called Corning is the one that supplies Corning Gorilla Glass, which is very famous glass that goes on smartphones, tablets, laptops, etc. It's like the number one glass. It's all started from the first iPhone 1 when they have this big problem and Corning solved it for them. And then Corning, they have Gorilla Glass 1, 2, 3, 4, 5, 6, 7. And when we tried to work with Corning, which I tried to contact them a couple of times, and every time we get rejected. But I kept insisting, I just wanted to meet a manager there. I don't want to meet the sales guy who just reject me because our quantities are too small or we are not noticeable and not listed anywhere. We're still a new company. We kept trying until we get the attention of some of the big managers at Corning, which we have we are one of the companies that has a weird request on glass. So our glass, usually the glass in the market is 0.8 millimeter for screens on the smartphones. And our request was 0.4, so it was very thin. And the management were like, they don't get usually that type of request. So they were like, why this company wants that thin glass? And they looked at our website and they found out that, hey, this company has a great story and they're trying to build the thinnest, lightest, strongest, and most sustainable smartphone. And we have the thinnest and the strongest glass ever. And they thought that this is a great story. We got contacted by the managers, and not only being able to work with them, there was another challenge, which is you talk about something called MOQs, minimum order quantity. For them, it's like 2 million units or plus minus, I can't remember the figure. And we are starting with very, very lower numbers, like in the thousands. And that was another thing we asked them for, and we managed to pull it out. And we managed to pull out this thing over and over with our supply chain, with different suppliers, to go there with the ambition that we are going to be the next big thing. We have a great story, we have a great brand, and we have the vision. Together with the sustainability, future material science that we're building, we managed to get some of the suppliers to say, we've seen this before. We've seen this before with Apple, we've seen this before with Chinese companies who 10 years ago didn't exist, and now they are like the top 5 worldwide, for example. So they know this can happen again, and they can see, most of the suppliers, they can see that we do have the ingredients for that.
When you get into innovation, you surely need to be persistent and resilient, right? So I'm so glad you kept going, Firas. At the end, you basically built the world's first carbon fiber mobile, and you mentioned that one of the reasons you got into that is that it's a more sustainable material, and for the customers, it ends up being lighter, thinner, and stronger, right? And that also you can recycle it from those different sources as leftovers. So why do you think the industry hasn't adopted carbon yet in a larger scale?
Like your questions, there's different aspects here, the recyclability part and the carbon fiber part as well. So let me tell you what's happening in the industry. It's the same example of Tesla. When we say that batteries 10 years ago or 15 years ago were not ready for cars, but now you have gigafactories, you have batteries that are everywhere. In Germany, for example, all the big manufacturers of automotive, they start to adopt electric vehicles. And we see the same trend right now with a carbon fiber. The carbon fiber is not ready for mass production. I can tell you that 2 years ago, the process of producing a carbon fiber body based on a monocoque design, it used to take roughly around 3 hours and a half. When you say a body is a complex piece, it's not like the normal smartphone body, it's not the back panel and the middle frame, it's really like the whole structural and the skin all together. That's what we call monocoque. So that used to take 3 hours and a half. If you compare it to what industry has today, they have like plastic, aluminum, which on the injection molding, for example, it can take 30 seconds. So that's a huge difference. And then you can understand why the industry is not tapping into that. But one of the things we found out is that we know there is a way to improve that. There is a way to go close to the competitive numbers of plastic and aluminum. And one thing that we did this year, even during COVID, actually we took COVID we used it as an advantage where the whole supply chain was dead and we were not able to do anything. We have a solution for the next version, for the next year, that we wanted to improve that production time. But because of COVID, we were like, okay, the whole supply chain is dead, so what can we do? Let's work on maybe perhaps we can get the next iteration, the next version, production process, bringing it into this version that we're working on right now. And we have a challenge of like, this should be done within 4 to 5 months. So that was early beginning this year in January when we started. So by end of April, we managed to move to the new production process, and it was very successful. And it was much more reliable, much more automated, much more controllable in terms of quality, and most important, much more scalable, because we went down from 3 hours down to less than 3 minutes per unit. And that's a big, big thing. This is where we see ourselves to be the Tesla of the industry, because we are able to, in the future, to set ourselves as a leading to all other players who want to use composites, not only manage the scalability issue, but also manage other technical issues. And we want to keep R&D in that field as well. And we want, in the future, to license our technology to other players as well. And I think we will be able in the next few years to go below 1 minute. If we manage to go below 1 minute, then I think that would answer the question of why nobody is doing it. At that time, everyone will do. It's inevitable that it will happen. So that's from one aspect. From the recyclability point of view, also the new process that we decided to work on is much more recyclable. So what we use, there's something called thermoset, there's something called thermoplastic. Just to give you a quick, like, what is the comparison here is that imagine if you have a pan and you have making a pancake, and the pancake is liquid. Once you put it on the pan, it becomes a hard object. You cannot take it back to liquid. But if you have butter, for example, if you put it on the pan, it becomes liquid. Then you freeze it again, become hard again, and then you can't get it back to liquid again. But that's what's thermoset is what is like pancake. Thermoplastic is the butter example. This is very important because when you build products, you want to recycle them. If you have a thermoset, that's very hard to recycle. And it requires so much energy to do that. And you would waste a lot of materials in the process. With a thermoplastic, you're able to recycle materials. So the carbon fiber, it's called composite. The reason we call it composite because it's composed out of two materials, the carbon fibers themselves with a thermoplastic. So we're able to like really tear down the materials by heating them up in an oven in a process called pyrolysis, that you can separate the thermoplastic, PA thermoplastic, out of the carbon fiber, and you're able to separate the materials from each other. That's one thing on sustainability that we're doing, but also one another thing is that we got great people from some of the brands who are helping us now on solving the fair trade issues. That's another thing because, for example, when you have copper, gold, plastic, etc., it's just like all these materials getting sourced from different places of the world, and many things coming from Africa, and over there is like wars happening around sourcing materials. So we want to also make sure that sourcing materials is happening like fair labor conditions and fair trade certified materials. The last bit about recyclability as well, or sustainability in general, is about we really want the product to have a longer lifetime. We want the product to be easy to repair. And we want also to provide spare parts to consumers with low margins that they can buy the screen themselves. We give them a replacement kit and they can replace it, or the battery, for example. So there's 3 pillars on sustainability for us. We call it the 3 R's, the reduce, recycle, and reuse.
You have such a great story, a great vision, and I hope you're heading a successful road ahead of you. So this is the end of our first episode. The next one, we'll be discussing the impact of new technologies in the material science and what's next out there. So stay tuned, everybody. We'll be right back.
Future Hacker. Life. Path. Future.